Cool. So let me just quickly kind of remind you what we have seen last time. Okay, so last time I kind of quickly explained that this is the box you are familiar with, the Java Standard Edition, and you are now expanding that box with more skills in the JavaEE, which basically, as I explained, extends the Java Standard Edition. And this Java Enterprise Edition itself is really implemented in multiple servers. One of them happens to be Glassfish. The basic idea is your application will run inside this Glassfish, and this server will provide services to your application. That's the basic idea. Services, analogy to what I explained before, kind of a service department where you can request services, and you don't need to do everything yourself. Now, as you might already appreciate, that in a web application you have two parts, client side and the server side. Client side, zero change. It's all the same. The server side, of course, will change. Now the way, because of the limited time, I'm really just giving you where you need to zoom in. So you have three types of classes you need to create. One are the entity classes we discussed last time, just to hold the information. They just have properties, getters and setters and constructors. Nothing else. No logic. For those, there is no change. Zero change. Just to create using your normal, well-understood and well-practiced Java Standard Edition skills. Then, once you have these entities, it's time now to save them and read them back from some kind of data source. That's what 99% of applications do. They have some kind of data source where they read from and save to. Typically, that data source is a database. But for now, we are not touching database. We're focusing more on doing it in memory, just to focus on the repositories and the services. Okay? So, and we saw last time the repository, again, zero change. All the skills that you need to build a repository, you already know it. The only thing that we kind of saw quite new is this little annotation here saying Singleton to just tell the container or tell the server that that you want one instance of this class in the whole application. And the reason why we want one instance, because this list here is shared. We want all the users to use the same list. When they read, they see all of them see the same contacts. Let's say this is an organization. Let's say these are the contacts of the department. If any faculty comes, they will see the same list. Okay? And if we add a contact to this list, all of them will see it. But realistically, we don't do this in real life. In real life, we save that list to some kind of database, and then we read and write to a database. But the concept is the same. Later on, next week, inshallah, we will make this repository, read and write to a database. Again, when we do that, our services will not change. Our entities almost no change. Okay? So once our repository is ready to be used and it's tested and we're happy with it, it's now time to make it accessible through the web, because we want to call it from the web browser, maybe through some JavaScript. So if I have a JavaScript on the client side, as an example, I cannot just call this directly, because this is in a different world. You cannot call a JavaScript, you cannot call a Java object remotely and from a different language. It's a big ask. It's not something easy to do. They might be kilometers apart, and you want to call it remotely. Are you following what's going on? So the only way to do it is you need another layer that you build, which is called the services. And the services, they provide you that ability to call these methods remotely from the web. Okay? So you can call this get method remotely and get the list of contacts, and you see them at your client side. So that's why we have this last layer, which is the service layer or the service class. And this service, as I explained, all it does, it bridges these two worlds, the world of the web and the world of object-oriented programming. And it's very, very easy. You might be wondering how easy this stuff are becoming, because these things have been going on for the last maybe 12, 15 years. So a lot of work has been invested into this until it became so sophisticated. It's just you add annotations and magically things happen. Okay? So you might find it overwhelming, but the whole complexity is hidden from you. In these application servers, they do the hardware for you. You just ask them, you just tell them what you need to do, and they do it. So for example, in here, I'm just asking them, please make sure there is only one instance of this class. That's it, just add the annotation and don't worry. The rest will be taken care of by the application server. Okay? When I say application server, it's something that you can either buy or download. You can just here put Oracle Glassfish. This is a server that you can basically go and download. It's an open source application server by Sun. This is a long time gone. It's bought by Oracle. They need to update this page. Okay, now sponsored. Okay, yeah, they know it's Oracle. All right, so that's it. This is the one. This is for poor people. For rich people, they will go for something like IBM WebSphere. Something like QNB or and above, they will go with this. Exactly the same. They do exactly the same thing. Both of them, you take out your application from this server to the other server, they work exactly the same. Except this one, maybe let's say 10,000 users concurrently, and IBM will go for 1 million users. Okay? The Glassfish, if something goes wrong, go to the forum, put your question and pray that somebody will answer. The IBM WebSphere, some problem, call them. Before you hang up, they are there in front of you. That's the difference. That's the only difference. The rest is exactly the same. So you are buying the quality, not the functionality. Functionality, they are the same. All right. That's the idea. Now let's look at the services. Again, I'm just quickly reviewing before I move forward. So this is an example service. Again, I'm just using annotations to link it with the repository. And the annotation is very self-explanatory, as you can see. It just says, if somebody comes to /contacts, they will land in this class. And this class will have some method to handle this URL. Now, which method will handle it depending on which verb the request came through. The request, which verb was used in the request. You know HTTP requests? Yes. They use a verb followed by a URL. So in here, you might be wondering where is the full server name and the full path or full URL. So the full URL comes from the server. Remember, the server is something that's already running and listening and working in the background. And basically, you take your application and you put it in that server. So definitely, your application will be accessible at the server URL, colon, the port of the server, / the application name. Because on a server, you can have multiple applications. Okay? And then / server name / any path that you might have. Let me make this a little bit concrete because I really want you to understand this. So by the way, let me show you, this is not running. All right, so it is not like your normal Java application, standard edition. You just run it, it compiles and starts running on the virtual machine. That's not the case. Have a look when I start running, what happens. Lots of things happen. You see there is a little command here, glassfish starting. So first it will start the server, the glassfish server, and here it is trying to start a lot of thousands, if not millions of lines of code getting started. Once it starts, don't worry about it. All right. So once it starts, it goes to my URL. All right. Don't worry about it. This is the server. This is the server URL. If I go to the server, it says, oh, by the way, you are in the Glassfish server. This server is able to host. You can put in it as many applications as you wish. It's up to you. Let's say, when you buy an application like something like Blackboard, they will sell you the software. But you have to buy the application server to put the software in it. So let's say you buy Blackboard. If you can afford Blackboard, most likely you will not go with Glassfish. Blackboard is also very expensive. So maybe you will have some IBM or WebSphere server. So you buy it, that's another thing you buy and install and set together. And then you take your Blackboard application and you copy it in that server. And then, so this is the root of the server. This is the root of my application. I have CMS, I might have Blackboard, I might have banking, whatever it might be. And from there, I go to, let's say in our case, API/contacts. So when I go /API/contacts, I will land in that class I'm trying to explain to you. Here it is. Now you might be wondering, where is this API coming from? There is a little file that you don't need to worry too much about it. Even myself, I don't really understand it too much. You just need to have this file. This file says, okay, all the services will be accessible through this API/star. So you just have this file. If you are not happy with API, you can put something else if you wish. If you don't want API, just remove it, just keep slash.
So it's not the same functionality like the app we used to make in the WebStorm? I mean with the Node.js?
Same goal, different ways.
Yeah, but it's the app, right? Like it's the same.
It's kind of different.
Because
you can think of it that way. Yes.
And then you have the controller there, I mean the services separate.
Yes, you can think of it that way if it makes you comfortable. That is fine. But in here, this one is you can just ignore this file. Just copy it. Any services project, you will find this file. This file, all it says, this is the URL. Usually, people put services under API URL.
Yeah.
So because there is two types of web, as I explained to you. There is this one. If I just go here, this is the human web, which means there is some kind of user interface where the users will interact with my application. And by the way, don't worry about the interface because it's using some other technology that's we're not covering in this course. I will fix it to use jQuery. But don't worry about it. We are not even talking about the interface because the interface you already know how to do it. We will not come back to it. Even in your homework, in your project, you already know it. We are focusing only on the repositories and the services and the entities. In your homework 4, the interface is already given to you and will be given to you in homework. Same interface you use in homework 2. That's anyway, I will be giving you homework 3 as well for your reference. Now, this is the human web, and the programmable web usually is under API. / some other. So even in Google, let's say, have a look. So anything you can do in Google, this is the human web. This is where users go and make use of Google services. And there is the API. If I do here Google API, so just a little bit, just to see, okay. Well, let me see. I just want to show you that there is another API, another URL to deal with. Okay, just want to see one URL. So let's see, I just want to do, by the way, anything you do in Google by user interface, you can do it by code. Okay, so let me see what I can do. Let me see this one, just as an example. If you have an address, you give it the address, it gives you the coordinates, or vice versa. Just want to see the URL. No. Where is the URL? Alright, let me see this one. No, there was a demo code there. You got the idea. Okay, no problem. Just give me 1 second. I will just try it. I just want to see. Okay. It's not as easy as I thought. Anyway, let's go back to this. Well, just to summarize, is when you are developing modern web application, you always think of two kind of users. These are the normal human users, and there are the other, like where you provide the programmatic access to your application. Other programs can come and make use of your application. Other programs means a mobile application or JavaScript application or other programs. Okay, and typically you put different URLs, and in most cases people use API / the programmable web is under API, and the human web is before the API. You get the idea. All right. So at the end of the day, when I go to contacts, I will land into this class. Okay. You see here, the purpose of this whole JavaEE technology is for me not to deal with the low-level details, the low-level communication details. How did the requests made all the steps to come to my class? It's not my job. It's the job of the application server. Okay? I didn't really do anything to route the request to this class. All I did an annotation to say, if somebody comes to /contacts, I want you to come here, and then work out which of these methods you will be calling. So in here, have a look here. This one is, as you know, it's a GET request. I can even prove it to you. Here is the inspect. And here is the, maybe the network. Let me just run it. And here is the contact. All right, can you see here? This is a GET, and this is where it's going to. This we don't care because it's not under our control. This is the name of the server. This is the name of this is the port. This is the URL of the whole application. Because I might have multiple applications on the same server. I'm paying here a couple of millions not to host one little application. I put as many as I wish. Each one will have its own root URL. And for me, I don't even care about this one. This one is also configured once in that little file. And then this is where I start from. Okay? So when I say path, this is what I put in my class. Just this little path. And then I worry about which verb the requester have used to come to my service. So, and then I do the mapping using annotations. So that's why if you understand HTTP, this will make sense to you. If you don't understand HTTP, it's a bit of Chinese. Okay? So in here it says, if somebody comes to /contacts, they will land in this class. Now, of course, this class, for it to do its work, it relies on the repository. Because I'm in a serviced container or a serviced application server, I don't need to create instances myself. Just ask for it. So you want in a hotel, you want your room done, just ask. Don't worry about how they will get that room service person. It will appear out of your door and do the job and go away. Okay? So the same thing. I need a repository, just declare it and add this annotation inject. And let the server worry about giving you a reference to a repository. Okay, now, in here, if somebody comes using a get /cities/country, this is not the one we are using. This one I'm just coming to contacts. So I'm saying, no, this is not the one that will be running. Let me see the next one. Next one looks likely. Because I'm coming to /contacts and landing in get. Okay, so this is the one that will be handling my request. And you see what it's doing? All it's doing, first of all, it's promising you to give you JSON. So you add this annotation, produces what is the data format the users will expect. You tell them, I will be giving you JSON. And then I basically go into my repository, getting all the contacts, and then I'm serializing them to a string and returning them to the caller. The way I return it, I would say return response .ok, this is the status. And this is the string that will go into the body of the response. And then I say .build. Now you've been wondering why this syntax. This is the way they have designed it. We read the documentation, we follow the documentation. So it's not something you need to be too creative about. That's the way they have designed it. But it is intuitive because you can see there is some annotation that maps the web request with my method. And we know that HTTP is all about a request response. So I will be sending some response. And that response always has some header, which is the status code. So this will be the status code OK, 200 OK. This is the body. And then I say, take these two pieces of information, the header and the body, and build the response and send it back. Anyway, this is the normal Java culture. They try to be too explicit. For me, it would have been just response OK.json semicolon or something like that. Or even something simpler than this. But this is the way I have designed it, we just follow it. Is clear? Yes. Okay, now, if somebody comes to, let's try it, /contacts/cities/QA. All right? That's it. So somebody came to cities/particular country. So let's see who is the lucky method that will get this. Are you the lucky one? Looks like. Because it's coming to /contacts/cities, and this one is a parameter. Okay? So this parameter, I want the glassfish to take this parameter from the URL and assign it to this parameter of my method. You see, I'm just basically mapping, bridging the two worlds. The world of the web and the world of Java programming, object-oriented programming. Okay, so this will be kind of captured and assigned to this variable by this annotation. Say this is a path param, which means go to the path, extract this piece of parameter coming from with the URL, and I want you to assign to this. Okay, and here again, same thing. I'm promising to return JSON. And here I go to my repository, get the cities for that particular country. Here, just this is for the this is to say, okay, this is what I return. This one I serialize it to JSON, and then I return it using the same pattern: response.ok.json.build. Is clear so far? All right. So this one we saw. Let's now, if somebody comes to a particular one, a particular contact, let's say 1. See here, I get a particular contact, but I got it in XML format. Okay, so let me see if I'll be lucky enough to get this to work with this postman. Okay. Yeah, wow. All right. So here is get, and here is my post it here, send. Internal error. Very strange. Yes, we experienced this last time. JSON, XML. For some strange reason, I have to investigate it. Let's not waste time on this. This is supposed to work because it's very strange. Exactly the same. It's working on the other one, not working in this guy. All right. For some strange reason, I'm not sure why. So this one is to be investigated, unfortunately. But in here it works. So let me explain this one.
But we have to return it in JSON, right?
Yeah, if I want to return it in JSON, I will explain the secrets, how these things works. All right, so let me come back here. So in here, so if somebody came in using a get,
After that,
yes, I will explain what's going on. So in here, if somebody comes to slash contacts, that is annotated in the class level, slash particular ID, this one is a parameter, that's why I put it in double curly braces. And I do the mapping. I want you to extract this ID and assign it to this contact's ID. All right? This one, and then I say, all right, I go to my repository, get that particular contact. If I find it, I will return it with an OK. Otherwise, I will return status similar to Node.js. Status that's found, entity, and I pass the message. Okay. You know, the API is a little bit verbose, a lot of calls and messages. Okay, here is the thing. This is the way it should be implemented in all cases. Here, I should not really do the serialization myself, but unfortunately, if I just return them, let me just try it. The Java serializer, it does not know how to serialize lists correctly. That's why I'm serializing myself. But really, I should do it this way. Let me just try to save this guy. Okay, save. It should, when I save, it should deploy by itself. Okay, I don't need to do anything. Yeah, but I will explain this. Let me just try it, which just to show you that maybe it will break. Let me see. See here, internal error. So, because this is a list, the serializer that comes with JavaEE is not powerful enough to serialize lists. That's why I say, okay, don't worry, I will do it for you. I'm not supposed to do it for it. It should do it by itself. But, you know, because I want to deliver my work, I'm not going to fight with this. So as a workaround, I'm using a third-party serializer, which is the JSON serializer. It's an open source small library that will do it for me with no headache. Okay, and then when I save, come back. Yeah, you see here, it works. It works just fine. Because there's a plugin, when it detects a change, it will reload the page by itself. So whenever you save, so whenever you do any change and save, have a look. Like for example, I just do this. When I save, have a look at this, deploying. You see it? Somewhere deployed. So you just change, save it, auto deploys back to the server. So your application needs to always be copied to the server. All right? Okay, so the reason why I am serializing, as I said, for it is because it's a workaround of that limitation of the serializer. Now, if it is a simple object, serializer does it very, very well, without me doing it on its behalf. And it gives me that ability to choose between these two between these two data formats. So let me try Chrome if we are lucky enough to say Firefox. Okay. Firefox also has a plugin. I'm just wondering whether it's a problem coming with that Postman or some other problem. So REST client plugin. Okay, debugger, advanced, Postman. Postman always comes first. Okay, let's try this. Not very good rating. Any other alternative? Okay, we'll give it a go. Hopefully it will work. So I'm just trying to have some alternative one just to see why this guy is not working. Okay, where is my... Where are you? Is it this one? Yes, this one. Okay, looks good. Let me get my URL. So if it doesn't work, it means it's from the server side. Some problem on the server side. I suspect it is from the server side, but let's just give it a go. Oh, good. It's coming. Good. Let me do one more thing, which is headers. Custom headers. I want accept and application /JSON. Okay, and send. Didn't like it. Application /JSON accept. It didn't like it. What is the internal error? Yeah, there is something on the server side. So I will investigate this. This should work, and it was working before. So the server is trying to do something too smart that we didn't ask for. But anyway, the idea here, suppose it works. The idea, let me just go back. The idea, I can ask the server which format I want, whether XML or JSON. Okay. Now, if it is XML, I will get the XML. Let's try here. Let's try /XML just to see, and then send. This one works. JSON serializer is the one we have problem with. So how do we tell the server which format do we want? No. How to us as the client? How do we tell the server? The header. Which header? No, which? Yeah, I know the header of the request. But which one? There are many headers. The request can have many headers. It's in front of you.
Yes, accept.
Accept. So there is a header, HTTP header called accept. What this header is for?
For the format.
Which format you wish.
Yes.
So when you go to a server, you can ask which format. Say, give me HTML or PDF or Word or XML or JSON. Of course, if it knows how to give it to you, it will give it to you. Otherwise, it will give you what it has. Okay? So accept, by the way, it's nothing to do with the service. It's a header in HTTP that allows the client to tell the server which format it wants. Okay? So, in this case, this is very, very smart. Have a look. I'm saying this method can produce either JSON or XML. Who decides which one to be produced? The client. How does the client specify which format to take? From accept. By adding an accept header. So if that plugin works, or there is a little bug here that's not in our code, some bug in application server, or some little thing that needs to be fixed. If it worked, I could have asked for .xml /xml and I get so. Sorry, I'm just annoying creature. Okay, so if I asked for accept application /XML, I'll get an XML response. If I do accept application /JSON, what do I get? JSON response. Okay? And the serializer, this is very smart. It will do that, what is known as content negotiation. Content type negotiation. All right. So this is for get. Now, if I want to add something, I will use post, as you already know it. And here I am not producing, I will be consuming. Or I might be producing. If it is produced, I will have produced. But in this case, I'm just consuming. So I say consuming means there is some incoming requests. In the body of the request, there will be the contact, either in XML format or in JSON format. And then here it will be auto-deserialized to an object. So the request will have something like this. Let's try it, although I'm very, unfortunately, a little bit pessimistic on this will work. So the way I will say it, the way I will do it, I will say, come here, go here, go to post, and I want you to send request. Where is the, oh, here, thank you. Here is the request, here's how it looks like. And here, I will just, instead, I will add another header. It says the content type. Telling the server what type of data I am sending. Application/JSON. Okay, all right. And then I'll go for OK. And supported media type. Thank you. Why is it?
لأن أنا حطيتها بطريقة الجيسون، طلبنا جيسون صح؟
No, مش طلبنا احنا الآن نرسل. We are sending. We are sending. So when I'm sending, I use this. Why didn't I add it? Okay, let's try one more time. Content type. You look, accept header, you use it to tell the server which format you are requesting the server to send you. Content type, you are telling
what you are sending.
Yes, you are telling the server what you are sending. Also, the server can tell you what it is sending to you using the content type. Okay. So, content type, what is the content type in here? Application/JSON. Doing any spelling? No. Looks fine. Save. So where is the header? I should see some kind of header here. Send, okay. It says unsupported media type. Anyway, let's try, let's try the other guy. Let's quickly try Postman here. Here is the Postman is the best, to be honest, but I think there is a problem in the server side, not the client side. So here is the content type, application/JSON. Okay, here is the body of the request. No, sorry, not this one. So let me go back here, pick up this.
Here we're adding this one.
Yes. Here is the contact I'm adding. All right. Hopefully, if things work. Okay. No, server side. Internal error. No, there is a problem. Sorry. No, there is a little bug. I will explore it and tell you work around it. Not in our code. There is some configuration bug or something. In the new version, because this I used to use it before. It works perfectly. So I will explore this one and let you know how to fix it. But is the concept clear?
Yes.
I'm doing a post, and the recipient of this post can either accept XML or JSON. How do I tell the server which content I'm sending?
By header content type?
Yes, by the header content type. And these are the type of questions you will get in your theoretical exam. For example, what is the difference between accept and content type headers? What's the difference?
The first one, the user would what it accepts JSON. The second improves when the user will tell what it's sending.
Yes, or vice versa. The server is telling the client. Yes. Okay, so that's basically the idea. So here, post is for add, put is the same thing, but it does update. Okay. If everything goes okay, you will get a 200 okay. If there is an error, you get server error with some message. And finally, there is a delete. But the delete, you have to send it to a particular ID, and then it will delete it and send you 200, okay, everything goes fine, otherwise it's server-side error. That is basically the idea. Now, one more thing I want to show you before you go. There is here servers. You can see here Apache. Sorry, it's not shown. All right, it's a bit. All right. Can you see here? In terms of servers, there are many servers. Yes, this one is poor, but this one is even poorer than the poor. The Apache Tomcat. That's another server. It's called Apache Tomcat. Yeah, because it does not have all the features. So Glassfish, I will explain this in more details later on. But Glassfish is a fully featured, has all the features of the JavaEE. Tomcat has subset of those features. Okay, so what I can do here, I can go and start and stop the server if you wish. I can also view the administrator console. Where is it? I think basically so there are some people, their job title is basically application server administrator. Let me see, is it 8090? Let me see. Okay. No. Okay, properties. I just want 48. Let me try 48. So the server has an administrator console. Is it 48? Yeah. So these application servers are not something simple. It's a complex piece of software, and some people, that's their job, is to take care of that server, make sure it's always up and running, always properly configured, and so on. So similarly, we have database developers and database administrators. We have application developers and application administrators. So if you go to ITS, you will find developers and administrators. So this is what administrators, although again they don't like they don't like something like this. They usually like to do it, through commands, because this one, it makes their job at risk. It sounds very simple. Okay, here it is. So when you come here, you will see that these are the applications that are running on this server. Here is my application that I showed you before, that we are currently running. Okay. Don't worry about a lot of stuff. It doesn't matter at this stage. Okay. Here is the application running. You can also, let me see. Okay, here, if you have an application, let's say you buy an application, you download it from somewhere, you can deploy it. When you download it, it will be a file with a .war extension. Normally it is Java, but for a JavaEE application, the extension of the application, it's a zip file with the extension .war. So you just click here and you browse and you pick up the application and you deploy it. Let me just try to see if I can just do it very quickly here. Just give me 1 second. Here it is. So I'll go here. Sorry, I'll cancel this one. I'll come here and say, all right, so just clean build. And I just want to show you where it is. You already see this WAR file. Let me just go there. Here it is. Control C. I will come here. Control V here. Okay. So you see the whole application was packaged in this little file here. Let me now, I will just go here, localhost. Remember that port? This is the administrator port. Of course, this is open now, but you can secure it and put some administrator password. So here is the application up and running. Okay, because I cleaned it. When I said clean, it removed it. Because I want to deploy it manually, just to show you another side of the application server from an administrator perspective.
But who specified this port?
Sorry?
The port for administration?
When you install Glassfish, you can, if you want, you can specify those ports. But when you install it, there is some default, but you can also always change this stuff. Okay, so here I just keep everything as it is and just save it. And now the application is deployed. And I can here, the application now is deployed. All right, I can come here and just do launch, and it will open it. Okay, you get the idea? And I'll go here and say /API/contacts. Hopefully you get here's the contacts. Okay, you get the idea? So an application, JavaEE application is you build it, you take it, you put it on the server, and it will make use of the services in the server. Okay? That is the whole idea. So I think this is enough in terms of JavaEE. Next time we will see how we can make use of JavaEE to make it easy for us to read and write from databases, relational databases, in 351. And the purpose again is to link these two courses. How you can, so it's not all pieces hanging around. I'm trying to link what you already know with the new stuff that we covered in this course. All right, thank you very much.